Alright, Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera to Dr. Fahmi, lecturer of class EE2427C and my fellow classmate. Alright, today my name is Ali Umar bin Muhammad, and today my teammates and I will be presenting chapter 1 of the subject Engineers Society, subject code EEE 610. My teammates are Amilur Rafiq bin Khairul, Wan Muhammad Syafiq Zufari bin Wan Sulaiman, and Syed Hazwan Hafiz bin Syed Haizil. Okay, so let's get to it. For this chapter, I will be presenting definition of engineering, part 1 of chapter 1. Okay, so engineering. Before I begin, what is engineering? So engineering is derived from the Latin word ingenium, meaning cleverness, or ingeniere, meaning to design or devise. So the definition of engineering is an activity to identify needs and solving problems. Basically, engineering is to identify needs or problems and then come up with solution to satisfy the need or solve the problem. So what do engineers do? Before that, what is an engineer? An engineer is a person is someone who applies the concept of engineering, meaning identifying needs or problems, analyze the needs or problems, and then use tools such as science and mathematics to solve them. Okay, so for example, two villages separated by a river. So the two villages, they often interact among themselves for business conducts. Okay, so they travel to each and fro using boats or sampan. Let's say one day the river is infested with crocodiles. So the option of traveling via sampan might be a bit dangerous, since the crocodile might attack the sampan. So how do we solve them? As an engineer, you analyze the problem, which is the crocodiles, and then identify the needs, which is to allow people to cross safely. So an engineer will come up with a bridge using science and mathematics to ensure the bridge is stable and also economical, therefore allowing people to easily travel to and fro each village and thus continue with their everyday lives. So that is engineering. The person who built the bridge, who designed the bridge, will be an engineer. Therefore, fulfilling the concept of engineering, which is identifying needs or problems and solving them using tools such as science and mathematics. But wait, you must be thinking, scientists also use science and mathematics. Well, that is true, but what separates scientists and engineers is that engineers, we immerse into the knowledge of science and mathematics like scientists. However, we apply them to our solutions to overcome the problems or satisfy the need. Scientists use the knowledge to come up with theories and formulas. Okay. So engineering, right? So you can see here we have civil, mechanical, electrical, and chemical. What is it actually? Those are branches of engineering. So, okay, all of this started first from military engineering. In the early times, the first concept of engineering is military engineering, meaning that at that time, we can see proof of engineering in war equipments. People at that time used engineering to fight battles and win wars. Let's say to siege a castle, they come up because during a siege, the castle will be in lockdown, the people inside, and they survive on the food rations they have. So how to draw them out? We have to use tools. That's why with military engineering, they come up with equipments such as catapult and ram to lay siege on the castle. With catapults, they throw fiery projectiles, and then making the people inside feel threatened, and sooner or later they had to surrender, and that's how they went. So it started from military engineering, and then civil engineering becomes was built, not built, sorry, was founded because they need to build buildings and everything. Civil engineering, so build buildings and other stuff. Then come up with mechanical, when machinery starts to appear in our lives. Then electrical, as time move on, and finally chemical engineering, where we study chemicals, composition of foods, and to make food better grow. All of these branches were created as the time moves on and the requirement for it happens, right? So as population starts to increase, need more place to stay, so civil engineering comes up with a solution to build more stable buildings or higher, from just single house to now penthouse, condominium and everything. Mechanical, as from the first car to cars nowadays. Electrical energy, as usual, since now everything is electrical. And chemical, during the shortage of food during war, so they need to find some way, so they study the composition of food and then create food that can last longer. So that is chemical. From there it expands more. Now we have oil and gas, then we have aeronautical, fly and aerospace, to fly rockets to the moon, Mars and everything. So it evolves, engineering evolves as time goes on, as the needs increases. So as you can see here, all these people are examples, like Elon Musk, Jeff Bezos, Satya Nadella. Elon Musk, CEO of Tesla and SpaceX. Although he is not engineer, but he studies. He is a self-learned engineer, meaning he read books all about engineering and then applies it to his products, and therefore fulfilling the concept of engineering. Elon Musk is Jeff Bezos was an electrical engineer, which he used to develop his company, and Satya Nadella is the CEO of Microsoft, who launched Microsoft to the next level to compete with Apple, its main rival. So what I'm trying to put here is that all these people, they are rich, of course, successful, and CEOs of their own company. Before this, a CEO is someone who has a master's in business administration, but this is not the case any longer. Nowadays, many CEOs are those who are from technical backgrounds and engineers. See, such an example as Satya Nadella. Before he took over as CEO of Microsoft, the company was declining, with the former CEO only focusing on coming up products to match Apple. When he took over, he saw the need to launch Microsoft to the next level, to overcome Apple's increase in sale by coming with new products such as cloud management. So that means the data can be saved via cloud and no longer just going on the space on your computers. That is an example of engineering, utilizing software engineering, still a definition of engineering. So all of these people, they are engineers. Basically, what I'm saying is that they are engineers, and they manage to launch to great heights. An engineer is not just someone who just listen, a lackey who takes orders from the boss, the top management, and then tell his underlings. No, an engineer can also become a CEO nowadays. 46% of the current business are CEO. Their CEOs are those who are engineers. As shown here, Thomas Edison, the father of engineering, one might say, a famous American engineer. So he has stated once, "I have not failed. I have just found 10,000 ways that won't work." So you can see engineering is not just concept. It's you can say that engineering can become. So with engineers, we are not just those who are in charge of project that will report to the top management, those who are from business background, business MBAs holders or everything. No, we are now stand beside them or might be higher, because we know the products, we understand the solution. People from those background might just concern about numbers, but as an engineer, you concern about the products more. See, I will show you a video after this on the engineering. Why CEOs are now becoming better engineers are now becoming better CEOs than CEOs of the past. See, why and engineers are now holding the position of CEO instead of those who are from business background. Alright.
There's one similarity between Amazon and Blue Origin's CEO Jeff Bezos, Apple's Tim Cook, Alphabet's Sundar Pichai, AMD's Lisa Su, General Motors' Mary Barra, and NVIDIA's Jensen Huang.
These days, the heads of some of the most successful companies in the world have one thing in common. They're engineers.
For those who aspire to be CEO of a company one day, getting an MBA, a Master of Business Administration degree, used to be the way to go. But that's not so true anymore. Harvard Business Review used to publish an annual list of the top 100 best performing CEOs. In 2018, they found that for a second year in a row, there were more CEOs with an engineering degree than an MBA, 34 compared to 32. Some had both. Getting an MBA can come with a hefty price tag. Top graduate schools such as the University of Pennsylvania's Wharton or Harvard Business School will set you back over $200,000. Now, some CEOs are telling you to save your money. Elon Musk went so far as to say, "I think there might be too many MBAs running companies," in an interview with the Wall Street Journal. He thinks those with business degrees spend too much time in board meetings, poring over PowerPoints and finances, when their focus should be on the product. The thinking being that if the product is good, the profits will follow. In the case of Musk, that means building great electric cars at Tesla or great reusable rockets at SpaceX. That's where being an engineer is helpful. Engineers can design, build, create, and improve their product because of their background in math, science, and technology. And they can help solve challenging technical problems that might otherwise scuttle their dreams. Technically, Musk has a degree in physics and economics, not engineering. He's a self-taught engineer who read books to learn about rocket science. When engineering consultant Sandy Munro interviewed him for his YouTube channel, Munro Live, he said it's Musk's knowledge that stands out.
I was blown away. I've seen dozens of CEOs. I've never seen a CEO ever, or a president, that knew more about the product.
That technical know-how that comes with an engineering background goes a long way toward building better products.
Just ask Satya Nadella, the engineer at Microsoft who rose to become CEO. When he took over the top job in 2014, he had to figure out a way to make Microsoft relevant as it faced an onslaught from Apple.
We now need to make Microsoft thrive.
The software company struggled to thrive under the leadership of his predecessor, Steve Ballmer. Its products were far from revolutionary. The Surface was a response to the iPad, the Windows Phone an answer to the iPhone. Ballmer has a degree in mathematics and economics from Harvard, which helped balance the books, but didn't do much when it comes to innovation. When Nadella took over, he transformed Microsoft, moving its software to non-Windows devices, for example, bringing Microsoft Word to the iPad and the iPhone. He also expanded its cloud business, Azure, which has become the biggest rival to Amazon's AWS. In his first email to employees as CEO, Nadella wrote, "Our industry does not respect tradition. It only respects innovation." That innovative spirit of engineering saved Microsoft. But it's not easy. It requires risky moves and not accepting failure. As American inventor Thomas Edison famously said, "I have not failed. I've only found 10,000 ways that won't work." James Dyson, the British engineer, knows a thing or two about not giving up. He became frustrated when a vacuum he had at home kept losing suction, so he decided to build a better vacuum himself. He he spent 15 years tinkering with over 5,000 different prototypes to come up with the perfect bagless design.
I'd like to give you a little demonstration.
The payoff for his perseverance was a multi-billion-dollar company that bears his name. In order to be successful, Dyson was invested in the fine details of his company.
Engineers aren't afraid to get involved in the day-to-day business, especially when it comes to hiring.
Amazon is notorious for tough interviews. Bezos, who has a degree in electrical engineering and computer science, used to meet every candidate himself during Amazon's early days. He would ask quirky questions like, how many gas stations are there in America? He wasn't after the right answer, but wanted to see whether the candidate had an analytical approach in order to come up with an informed response. Bezos once said setting the bar high for hiring was the most important factor for the online retailer's success.
It's no surprise that engineers make it to the top of the tech industry, which has seen explosive growth over the years. But they're also doing well at non-tech companies.
Like Jeffrey Sprecher, the CEO of the holding company that owns the New York Stock Exchange. He has a degree in chemical engineering.
And I've never had a job that had anything to do with chemistry, but the discipline that I went through there taught me about problem solving, and business is really just that.
Engineers are very good at solving problems, and that's the key to doing everything from building a bridge across a river to designing a rocket to get to Mars. If you've been inspired to become an engineer or simply want to learn more about the world, a good foundation in math and computer science is crucial. A problem-solving website.
So as you can see from the video, that it says nowadays no longer those who own MBAs are just CEOs. Engineers also. As stated multiple times by those by examples in the videos, as engineers we care more for the product than the numbers. Although I'm not saying that without numbers that we can just succeed, but a major percentage is based on the product itself. As engineers, we immerse ourselves to ensure that our product, whatever products to satisfy the needs of the public, are delivered with 100% at 100%. So that's why engineering is an important part, especially as time goes on, as stated in the video. As time goes on, more areas are introduced, and those areas requires, as stated by the CEO of Holdings company, who has a degree in chemical but never held a job with his field. But what he said, what he learned during university, he applied the problem-solving skills that he obtained, applied to his business, as he said, so making his company grow. So that is engineering. So, in conclusion, as Thomas Edison once said, I have not failed, I have just found 10,000 words that word. It's the definition, it's the fine print, it's the heart of the engineering. As engineer, we cannot just give up. We cannot just give up at the first amount of failure, the first sign of failure. We strive, continue until we succeed. Failing is not when you fail. It's not when you fail. Failing is when you choose. Failing is not when you fall down. Failing is when you fail to get back up. As long as you're willing to get back up, you are successing. So that is all for me. The next part of chapter 1 will be presented by my teammates. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Muhammad Shafiq Tufaili bin Sulaiman, and today my part I will tell about engineering branches. So basically, engineering are divided by 4 main branches. The first I want to talk is electrical engineering. Second is mechanical engineering. Third is civil engineering, and lastly is chemical engineering. These are the 4 main of engineering branches. There are more branches there are more branches. Inside these are 4 main branches. I mean, just as example, to student electrical engineering, there are 2 types, right? Electronic and power system. That is as far as we know. They are the branches of the main branches. Okay, now let's go to the next. So, electrical engineering. So, electrical engineers, basically they are focused on designing electrical supply or electrical equipment. So, the keyword for this electrical engineering is electrical. They are designing electrical things. So let's see what else in the electrical engineering do. Electrical engineering is subdivided by lot of range of fields. As we know, there are lots such as electronic, digital, computer, power engineering, control system, radio frequency. But I will tell more about this. I will tell more about this job scope. I will tell more about this job scope after I briefly define the other engineerings. Now, let's go to the mechanical engineering. Mechanical engineering is engineering a science method about they are designing and also develop and build like electrical engineering, but they are more specifically to mechanical things, or should I say they are more related to metal, something like that. Yes, metal and machine. Touch mechanical device, tools, engine, and machine. So, what is the range of field of mechanical engineering? So, mechanical engineers, they are more to dealing with generators, engines, turbines, also engine part, aircraft, control system, printer, semiconductor, robot, machine, and I think more to big things. I think are more related to mechanical things. So that is what mechanical engineering do. Inside the building, they are also work with elevators and escalators. So now we are on civil engineering. Civil engineering conceive, design, and build the supervise, operate, and plan, construct, and maintain infrastructure. So basically, for civil engineering, they are more to building support our life. They are different from mechanical and electrical. Civil engineering is more to make our life more civilized. Am I making? They are basically dealing with buildings. Yeah, more to that. They are more dealing with project about buildings. So from here, they are referred to as civil engineering. They help get water, electricity, people, and goods from place to place. That's what I mentioned about they are building civilization. So this is what civil engineering do. Civil engineering do. So creating the network and facilities need to make transportation possible, including roads, highway, buildings, airports, tunnels, dam, and bridge. All of these items are the buildings that I just mentioned before. So let's go to chemical engineering. Chemical engineering develop and design chemical. So the keyword here are chemical. So chemical engineering work with chemical. So chemical the chemical thing that our daily life has been through is like fuel, drugs, food, and products. So the chemical engineer is also develop solution to environmental problems. Environmental problems such as where the river is polluted. So the civil engineering will create a substance to neutralize the pollution in the river, the pollution on the ocean. This is from my opinion. So now let's go to what the job scope of chemical engineering. So they work in manufacturing, pharmacies, healthcare, the design paper, of course. To make paper, there are a lot related with chemical engineering, petrochemical, food processing, especially food processing, and electronic. Electronic is branches of uh, electrical engineering, but to make the energy, we need a substance, a chemical substance. So the chemical engineering also related with electrical engineering. Alright, now I think I have explained about all the engineering, the four main engineering that we have: the electrical, the mechanical, the civil, and the chemical. Therefore, I have explained all of four of them. Now, I want to share. I want to share the job scope of electrical engineers. Since we are a student of electrical engineers, I want to more specifically explain what electrical engineer can do and how they work. Now let's go. Alright, number one, we have electronic engineering. Electronic engineering develop electronic small part products. So they are more focused specifically on electronic circuit and devices, such as the capacitor, the transistor, as anything that related with electronic parts. I mean the small parts in electronic devices. So that is electronic engineering. Now let's go to another. We have digital computer engineering. So basically, when I say about computer and digital, we have an idea. This electrical engineering job scope is related with computers. So the computers engineer, basically they design and build and maintain hardware in modern computers. This engineer focus on integrating hardware and software. So that is electrical engineering for digital computer. Now next, number three, we have power engineering. So when we say power engineering, we can understand that we are dealing with maybe more than 100 kilovolt voltage, 100 kilovolt of power. So that is what we call as power engineering. So let's see here, power engineering works on variety equipment and machinery, including generators, boiler, compressor, and refrigeration units. These all of these items, without a doubt, they are an electrical device that is consume kilovolts of power. So this is power engineering. Then let's go to the other part, telecommunication engineering. On number four, we have telecommunication engineering. telecommunication engineering is an engineer which is related to telecommunication system. As example of telecommunication is cell phone, telephone, smartphone we use on our daily basis to call our friend, our parent. So in this job scope, telecommunication engineering offer a connection for people to connect with others. Alright, now let's go to the number 5. We have control system engineer. Control system is basically, as we learned in previous year, as a student, we learn what is control system. So control system is a circle of it's a circle. Control system is related to input and output, and there are many parts in now. Number 5, we have control system engineer. Control engineering is engineering discipline that applies control theory system. Previous year we all learned about control system. Basically, to make that system or devices to receive a feedback, to know what is a good input and good output, to basically to make the whole system efficient. So that is what control system engineer is make sure that the system will behave in the desired manner. Alright, now let's go to the number 6. Number 6 is radio frequency engineering. Perhaps it's more likely same with telecommunication engineering, because telecommunication engineering also dealing with radio frequency, but perhaps this RF radio frequency engineering is more to design radio frequency equipment and products. Maybe their job is not related with telecommunication, which the telecommunication to connect people with other people. Maybe radio frequency is more likely to project that design, as this define say, design process to manufacture and distribution of the products. The radio frequency engineer are more likely to deal using this tool called oscilloscope. Whoever interested in doing this job, they can apply for this job. Okay, now let's go for the number 7, if I'm not wrong. Signal processing engineer. Signal processing is an electrical engineer subfield that focus on analyzing, modifying, synthesizing signals such as sound, image, and scientific measurement. So basically, this kind of electrical engineering job scope is more to measuring things, analyzing them. They are more to getting the data from their project. This is what I understand from this field of job scope. Alright, now let's go to the number 8. Let's go to the number 8. Instrumentation engineering. Instrumentation engineering is the science of the measurement and control of process variable within the production of manufacturing area. So instrumentation engineering, as I understand here, they are more related to doing job with instrument, specific instrument. I'm not sure, maybe they are checking the instrument. Okay, now let's go to the number 8. Microelectronic engineering. Microelectronic engineering is an electrical engineer specialized in design of integrated circuit. When I say integrated circuit, I mean this just scope is more related to electronic. It's more related to electronic uh, electrical engineering. They are electronic engineering. They are making small parts of electronic electronic parts. Microelectronic, they are making the same thing, almost the same thing with electronic engineering, but they are using the small parts. That is what I understand from this job scope. Now let's go to the number 9. We have hardware engineering. So hardware engineering basically they apply hardware skills. So in this content, hardware engineering is process of designing, developing, testing, and producing computer systems, or perhaps it's more to dealing with electrical devices. That is the meaning of hardware engineering. Now let's go to the number 11. We have power electronic engineer. Power electronic engineer is basically your job is to design and to test circuit to use in a power system electronic. Now let's go to the number 12. We have electromagnetic and wave electromagnetic engineering. So basically we apply electromagnetic theory and then electromagnetic theory that we have learned before related to inductor and capacitor, anything that related with electric and magnet. So with this theory we can create something like electromagnetic things like loudspeaker, or perhaps inside the MRI to scan our body, and magnets in electric motor. We have lots of types of motors that use magnet to make the motor move. So that is a big description of electrical engineering for electromagnetic and wave. So now let's go for the number 12. We have microwave engineering. So microwave engineering is basically an engineering to design communication and navigation system in the microwave frequency range. So the keyword here is microwave frequency range. Perhaps anyone who are interested to work in this field, perhaps they know more. So let's see here, the application for microwave engineering is microwave oven, this is obvious, radar, satellite, direct broadcast, personal communication, and more. I believe there is more. Alright, now let's go to the number 12. We have nanotechnology. Nanotechnology engineering. It quite remind me of Marvel Universe actually. So the nanotechnology is refers to branch of science and engineering devoted to designing and producing using structured device. So basically, this kind of field of electrical engineering, they are making electrical device, but in very small size. As you can see in this picture, this is an electrical robot. This is a robot. This is a robot, a small robot that working with our human body DNA, which is suitable. They are called as nanotechnology, which is they are very small. Now let's go for the number 14. If I'm not mistaken, we have electrochemistry. So electrochemistry is the combination of electrical and a chemical. So their job is consists in development of efficient, safe and sustainable technologies for production of chemical, metal recovery, remediation and decontamination technologies such as fuel cell, flow of batteries, industrial electrochemical reactors. So this electrochemistry, the combination of electric and chemistry, they are designing they are designing things that related with a chemical. So let's go to the number 15, which is renewable energy. Renewable energy is rapidly expand in our daily life because one day this renewable energy will replace unrenewable non-renewable energy that we use today, which is coal and fuels to generate the electricity. So, renewable energy engineers work on production of energy from renewable and sustainable sources such as wind, from the sun, hydro, and other climate that we can use to generate the electricity. So as you can see in this picture, the engineer is dealing with solar energy. Now let's go to the number 16. We have mechatronic. So what the idea we have here is mechanical is combined with electronic. So this mechatronic is basically an engineering that dealing with a robot, smart technologies such as robot, automated guided system, and basically more related to types of robots. Now let's go to the number 17. Oh, let's see. I think that's all from me. Thank you very much.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Rafiq bin Hairul. So today I want to present to you Chapter 1, Introduction to Engineering Professions. So my part is Do's and Don'ts of an Engineer. So the Board of Engineers Malaysia, we call it as BEM, has from time to time received inquiries and complaints from the public about the conduct of engineers in relation to the Registration of Engineers Act. So BEM has therefore produced the guideline for the engineers on do's and don'ts of an engineer. So these guidelines are set out under a number of broad areas relating to the engineering profession, such as electrical engineering, chemical engineering, mechanical engineering, civil engineering, and others. So without wasting any more time, let's go to the topic. So there are 5 categories of do's and don'ts of an engineer. So the first one is registration, followed by consultancy, and then supervision, regulatory requirement, and lastly code of ethics. So let's go first on registration. So let's go to registration. Under the Registration of Engineers Act 1967, or we call it as Act 138, the most recent being year 2002, it is a requirement of the law that any person providing engineering service be a qualified person and registered with the Board of Engineers Malaysia BEM. This requirement extends to foreigners who are required to see registration as temporary engineers. So, the first thing that we as engineer must do is an engineering graduate with accredited engineering degree like us must register with the Board of Engineers Malaysia BEM to take up employment as an engineer. So, we as a fresh graduate must be registered with the Board of Engineers Malaysia BEM to do any engineering service. So, that's it. And then we go to the don'ts. So, as an engineer, should not be the submitting person for the design beyond his or her area of competency. An engineer should not endorse his PE stamp and sign on reports or plan not prepared by him. And lastly, an engineer should not enter into partnership with any party not permitted under the Engineers Act. So, for example, if we doesn't know that thing or we not do the report, we cannot say that it prepared by us. So it is what we should not do when we become an engineer. So then we go to the next part, which is consultancy. So, for consultancy, in the Registration of Engineers Act 1967, revised in year 2002, provision is included for the registration of accredited checkers and the requirement of continuing professional development beginning in year 2005. So, what should we do in this category, which is consultancy? An engineer should be transparent and receptive to peer review or checking of his work if requested or required by the client or authorities. And then, a checker engineers must be open to the views and design concept of the original designer, and in areas of disagreement, the checker must give justification for his disagreement. And lastly, a checker engineer should take full responsibility for the checking of the work himself. For example, if any problem happen, then the engineer should take full responsibility without any exception. And then the second one, what should engineer prevent in this category? The first one is a checker engineer should not accept checking of work not within his area of competency, as well as work that he is not familiar with. Second one, an engineer consultant should not carry out projects for fees below the minimum outlined in the scale of fees. And the last one is an engineer should not endorse any work not performed and or supervised by him. For example, if we are fresh graduate, we're not familiar with many things because we does not have experience and exposure. So we cannot accept checking of work not within our area of competency. So that is one of the example. So then we go for the next part. Okay, now we go to the supervision. So, the supervision of work designed by the submitting engineer is a requirement under the Uniform Building Bylaw 5. We call it as UBBL 5. This bylaw states that supervision must be provided by the submitting engineer to ensure that the work carried out are as intended in the design. Delegation of supervision is permitted, but the responsibility of the supervision still rests with the submitting engineer. So, what should we do and what should we prevent in this category? So, we go do's first. An engineer who is the submitting person should be responsible for the project regardless of whether it is self-supervised and or delegate supervision. And then, an engineer must be meticulously proper and correct in certification of works. And lastly, an engineer must be familiar with and knowledgeable in the work he is to supervise. So, for example, you have a worker down you. So then, you must be familiar and knowledgeable in the work to supervise your worker, your team. Then, you have a very successful team. Okay? So, then we go to the don'ts. So, the first one is an engineer must not over or under certify progress of works. Second, an engineer must not make wrongful certification. And lastly, an engineer must not certify work not within his expertise. So, for example, if we're not expert, we should not certify that work. We must let other person who expert in that field do the certification. Okay? And then we go to the next part. Okay, so next we go to regulatory requirement. So, all engineers registered with the Board of Engineers Malaysia, BEM, must be familiar with the requirements of the Registration of Engineers Act 1967, or we call it as Act 138, and its subsequent amendment. Ignorance of the requirement of this act is no defense in the court of law in Malaysia. So, we go first on what should we do to be as an engineer in this category. The first one is an engineer should notify the relevant authorities within reasonable or statutory time limit on change in designs or withdrawal of services. So, for example, if in construction, for example, if there are any change or withdrawal, we as engineers should notify the relevant authorities so we can prevent any accident in the future. And then we go to the second part, which is an engineer should submit completed form in time for inspection and approval for certificate of fitness or certificate of completion and compliance. And lastly, an engineer should be aware of environmental, health, and safety matters during and after construction. So, an engineer must know the environmental, health, and safety to prevent any accident during the construction process. And then we go to the next part, which is what should we prevent as an engineer in this category. The first one is an engineer should not allow works to proceed before plans are submitted to and or approved by the relevant authorities. And the last one is an engineer should not undertake a project for which the client is not going to fulfill statutory requirement. Again, this is very important to prevent any accident to happen. So make sure that the statutory requirement is being fulfilled before we proceed to take the project. Okay, and then we go to the last part. For the last part is code of ethics. So all engineers are expected to uphold the integrity of the profession by behaving in a manner expected of him in the code of conduct of engineers. So we go first what we should do in this category. So the first one is an engineer must be conversant with the code of conduct of engineers. The second one, an engineer must understand the need for responsibility and liability as stipulated in the code of conduct. And lastly, an engineer must respond promptly to complaints and inquiries by clients or authorities. So, if the clients ask anything about the construction, for example, an engineer that expert in that field must respond promptly to the complaints or any inquiries that been asked by the client or comment by the client. Okay, and then what should we prevent as an engineers in this category? An engineers should not solicit or thought. Second part is an engineer should not knowingly mislead the public by giving misrepresented information so as to gain commercial advantage or mileage. An engineer should not respond to an open advertisement to bid for provision of professional service if such provision for the services requires bidding fees or equivalent as is usually imposed on contractors. And then that's it. What should we do and what should we do not do or prevent as an engineers? So the next part, I will show you the example of a disaster and what we need to do. Okay? Okay, so this is one of the example that I want to show you in category of registration. So this news is on 16 December 2019. As you can see, based on the news, Malaysia needs about 150,000 registered engineers. Even though engineering fresh graduates are hard to find a job, one of the reasons are because of they not registered under Board of Engineers Malaysia, or we call it as BEM. This, they cannot provide any engineering services legally. At that moment, registered engineers is 153,020 people. But we need at least 300,000 experts to reach developed country like US and also China. So when we graduate, we as a fresh graduate engineer, we must register to the Board of Engineers Malaysia to ease the process to find a job and to be professional engineer in future to help our country to reach developed country one day in future. Okay? Okay, next we go to the next example, which is it happened in Malaysia, which is Sungai Kim Kim 2019 chemical waste pollution. So, Sungai Kim Kim 2019 chemical waste pollution is a water pollution incident that occurred on March 7, 2019, caused by the dumping of chemical waste in Sungai Kim Kim. So, I studied in Pasir Gudang at that moment, so I also taste the effect of the pollution lah. So, several students and canteens workers from two schools near the river began to fall ill and complain of difficulty breathing until they were sent to Sultan Ismail Hospital in Pasir Gudang, Johor, Malaysia. The second wave of water poisoning occurred on March 11 with around 106 to 207 more victims being hospitalized before rising to more than 1,000 victims. So we can also see this example like Bhopal disaster, one of the assignment that doctor asked us to do. So the illegal dumping emitted toxic fumes affecting 6,000 people and 2,775 receiving treatment in hospitals. Most of the victims were school children. 110 schools were later closed along the river to prevent any accident happen, to make sure they not fall ill. So it is because of a tanker truck is believed to have dumped chemical waste into the Kim Kim River early in the morning. So that is the main reason that caused the chemical pollution in Sungai Kim Kim. So this related to our subtopic and under regulatory requirements. So as we can see here, an engineer should be aware of environmental health and safety matters during and after construction. Not only construction, but also at production fields and many more. So in this tragedy, the driver of tanker truck does not know the effect when they dump the chemical waste into Sungai Kim Kim. But the engineer, that person in charge in e-waste or anything chemical waste, must know that have a knowledge about chemical waste and safety environment, must advise the tanker truck
Driver
to not dump chemical waste. So this is one of the reason why we as an engineer must be aware of environmental health and safety matters. So that is the point that I want to show you about Sungai Kim Kim 2019 chemical waste pollution. Okay, next we go to the next example that I want to show you, which is Dhaka garment factory collapse. So the background of this example is the 2013 Dhaka garment factory collapse, also referred to as a 2013 Sabah building collapse or the collapse of Rana Plaza. So it was a structural failure that occurred on 24th April 2013 in the Sabah Upaliza of Dhaka district, Bangladesh. It also considered the deadliest non-deliberate structural failure accident in modern human history and the deadliest garment factory disaster in history. So I want to highlight the last causes of this tragedy, which is the use of substandard construction material. Before I want to explain more, the causes of this disaster is the building built on the field in pond which compromise structural integrity. The second one is conversion from commercial use to industrial use, which is the big mistake. And the third one is addition of 3 floors above the original permit. And the last one is the use of substandard construction materials. Okay, so this causes, the last causes, which is the use of substandard construction materials, I want to refer to one of the point in consultancy category, which is the don'ts. This part don'ts. An engineering consultant should not carry out project for fees below the minimum outlined in the scale of fees. So, based on don'ts of engineers under consultancy category, one of the reason the developer use substandard construction material is because of the price is cheaper but the quality is lower. So that's why it contributes to the causes of this tragedy, and this tragedy must be one of the example that by carry out project for fees below the minimum outline in the scale of fees can contribute to disaster in future. So alhamdulillah in Malaysia okay. Okay, let's stop. So let's go watch some video clip about Dhaka Government factory collapse. So let's go.
We're here at Rana Plaza. 2 years ago, in April 2013, a building housing several garment factories here collapsed, killing more than 1,000 people.
শুনি যে ইঞ্জিনিয়ার দিয়ে পরীক্ষা করছে, পরীক্ষা করার পরে ওই বিল্ডিং থাকবো না, যে 4 দিনের ভিতরে ওই বিল্ডিং শেষ হয়ে যাইব।
তখন আমারে পিএম স্যারও ডাক দিছে, তারপরে আমি উঠি নাই গা, সোবার বাজানেও ডাকছে, তারপরে উঠি নাই গা। তখন আমাকে লাইন শিপ ছিল মাকসু ম্যাডাম, সে আমারে নিচের থেকে নিয়ে গেছে।
None of the factories inside the plaza had unions, so it was hard for workers to fight for better conditions or refuse to work in a factory so dangerous their lives were at risk.
তখন দেখতেছে এরকম করে এমন একটি মানুষ গেটে দল হয়ে গেছে, কার মানে ওই দিন কারে মাইরা কেরা যে বাইরে আইবো এটার কোনো মাথার মধ্যে কোনো বেরিং ছিল না। তখন ওই দিন আমি আবার কি করলাম, ওই রেফাতে হাতে একটা ঘুষি দিয়ে দারোয়ানরে ঘুষি দিয়ে তারপর আমি বাইরে আসি। নিচে যখন এমনি উপরে পড়ছে, পিছন দিয়ে চাই দেখি ফ্যাক্টরি গোল গোল খালি ভাঙতাছে।
জ্ঞান ফেরার পরে মনে এতটুকু বিশ্বাস হয় না যে আমি বিল্ডিংয়ের নিচে পড়ছি, বিল্ডিং ভাঙে গেছি। আমার এতে যে নিচে যে একটা মেয়ের লাশ, তখন ওরা চিল্লাফাল্লা করে যে বিল্ডিং মনে হয় নিচ দিকে ডাবতাছে। তখন ওই মেয়ের লাশের নাক কান দিয়ে যে রক্ত বের হয়েছে, ওই রক্তটা আমার সারা পিঠ, আমার মুখ দিয়ে, নাক দিয়ে এক সাইড ভিজে গেছে।
Since the Rana Plaza disaster in 2013, when more than 1,000 garment workers died in a building collapse, and the fire at Tasreen Fashions, which claimed the lives of more than 100 garment workers, we've seen significant improvements to health and safety conditions in Bangladesh's factories. But we've also documented continuing and serious violations of labour rights, including workers who are forced to work overtime, sometimes without being paid for it, workers who are subject to verbal and even physical harassment, often because they can't meet production quotas, and factories that deny workers sick leave or maternity leave, even holidays.
আমারে দিছিল, আমি হেল্পারে ঢুকছি, সুতা কাটপার দিছিল, সুতা কাটপার লিয়ে যা দিছে, কাটার সহকারে দিছে, এলা সুতা কাটি 400 টার্গেট দিছে, এলা ঘন্টায় 20 পিস করে দেওয়া লাগবে। তার মধ্যে জুলুম দেয়, সমানে ইয়ে করে, বোকাবাজি করে।
1 মাসের 25 তারিখে 30 তারিখে এরকম দিত, কখনো কখনো 3 মাসের বেতনও পেন্ডিং থাকতো, দিত না। তারপর ওভারটাইম দেখা যেত যে 6 মাস, 8 মাস, 1 বছরও হয়ে যেত, আমি ওভারটাইম পেতাম না।
Workers try to form unions in order to advocate for better working conditions, but too often the management and factory owners will go to almost any lengths, it seems, to stop workers from forming unions. We've had cases where people have been fired and then blacklisted from other factories. There have even been cases of physical attacks where thugs are sent to attack workers who try to unionize, and also activists who are helping them to do so.
আর আমাদের আরেকটা ফেডারেশনে একজন ভাই ছিল, আমিনুল ইসলাম, ওকে মেরে ফেলছিল ইউনিয়ন করার জন্য। তখন বলতেছিল যে এই আশুলিয়াতে যে আমিনুল ইসলামকে মেরে ফেলছি, সেভাবে তোমাদেরকে মেরে ফেলবো, আর তোমরা আর বাঁচতে পারবা না, এই বলে আমাদেরকে খুব মারতেছিল। আর
it is the management, the failure of the management, which ultimately led to the question of establishment of the trade unions, and now establishment of the trade unions in the government sectors, in the factories, is a reality which cannot be negated, which cannot be ignored.
Majority workers are not aware about their rights, but when they come to know their law and rights, they're eager to organize union and form union, because if you don't have union, you cannot negotiate with your respective factory management.
Since Rana Plaza, many international brands have signed a new agreement to inspect and oversee fire and safety conditions in 1,611 factories. But the brands can still do more to ensure that abuses aren't taking place in the businesses that supply them. They should be transparent about where their clothes are coming from, which factories are supplying them. And they should also be ensuring that these factories, whether they're contractors or subcontractors, are actually properly inspected and that violations are fixed.
Some brands, they paid us last year $4.2. This time they're asking for $3.6, despite of so many complaint issues, so many things. So they have to also change their mind, because if they want to get so many things, they have to pay for it.
It's really up to the Bangladeshi government, factory managers and owners, and the international brands that source so many products in this country to work together to ensure the conditions are improved and that workers are able to exercise their rights as they're entitled under Bangladeshi and international law.
Okay, that's it, the video that I want to show you. The video clip about Dhaka government factory collapse. So the point that I want to highlight, the next point that I want to highlight is addition of 3 floors above the original permit. So based on these causes, we can refer to supervision category of do's and don'ts. So we see at don'ts here, an engineer must not make wrongful certification. So, based on this issue, is it engineer that give a certificate to do addition of 3 floors above the original permit? So we can see here that this is one of the wrong thing that the engineers should not do to prevent this accident to happen. So that's why we need to give a good certification. That means we do some research and we do some proper design to make sure that certification that we give is not wrong, to prevent a disaster like this to happen. So I think that's all that I want to share with you. So we can proceed to the next subtopic. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Syed Hazwan Hafiz bin Syed Haziq. I am from Group EE 242-7C and from Group 1 Introduction to Engineer Profession. So I will be present for the subtopic route to become an engineer. Firstly, definition of engineering ethics. Engineering ethics means rules and standards governing the products of engineers in their role as professional. First of all, I'm going to talk about the ethics in engineering, because to become an engineer, you must know what is the definition of engineering as that presented by my members, Mr. Ali, the definition of engineering. So, the body of the codes of ethics, there are some codes that you should know. So, engineers uphold and advance the integrity, honor and dignity of the engineering profession by number 1, using their knowledge and skill for the enhancement of human welfare. Second, being honest and impartial and servicing with fidelity the public, their employers and also clients. The third, striving to increase the competence and prestige of the engineering profession. Last but not least, supporting the professional and technical societies of their discipline. So these four core ethics is very important when you are in the field of engineering. You must use your knowledge to the right thing. You must be attitude, honest with your what you are doing, and you try your best to striving for the company, for the community, and also you must support. Even you are become a leader, then you know how to support your co-leader, your employer. In Malaysia, generally, we have 3 bodies of courts. I will divide into 3 groups, which are the Institute of Engineer Malaysia, IEM, Institute of Electronic and Electrical, IEEE, IEEE, and also Board of Engineers Malaysia, BEM. Engineers liability and obligation. Obligation placed on engineer are not principally limitation, but enablers of their practice. Engineers are highly valuable to society. Ethical obligations are necessary in order for engineers to carry out their profession. So I am going to little brief about the difference between engineers and scientists. Engineers' role to serve the following into 3, which are to God, our mighty God, our Creator. Second, to the society, which public, community, and also lastly to the community. So engineers, a creative designer and problem solver that applies the scientist knowledge and findings. And the engineer always tries to further improve a design and concept, while for the scientist, a person who gathers knowledge through research conducted in obtaining new findings by observation, experiments, analysis, and so on. For the graduate engineers student outside there, you should know that an engineer student who wish to work as an engineer must be registered with the BEM or Board of Malaysia as graduate engineers. The experience of an engineering student is only recognized by BEM after the student has registered as a graduate engineers. It is critical that all engineers graduates register with BEM as soon as possible after receiving their bachelor's degree, or you can call a scroll of your degree. So before applying for registration as a professional engineer or PE, a graduate engineer must have at least 3 years of practical experience in the field. So before applying for registration, a professional engineer or PE, a graduate engineers must have at least 3 years of practical experience in the field of engineering. The professional assessment examination PAE, which was previously owned by BEM and now administered by IEEE on its behalf, may be applied for you after you have satisfied all the preceding requirements. You will become a PE, professional engineer, if you pass the PAE or professional assessment examination and other membership requirements. The route for to become a professional engineer, there are 3 routes, which is route A, route B, and route C. Route A is mostly for the graduate engineer in university in Malaysia, while for the route B, usually is not recognized by university in Malaysia, or otherwise we can say that the university is from overseas. And for the route C, they are different, but they are a little bit different from the route A. Later on I will discuss the difference. So this is the route. The university must be accredited by the engineering degree to become the BEM registration. So the training requirement is 3 years minimum, 1 year in Malaysia if I don't mistake, and then you will become an engineer, but you will be interviewed for the professional engineer, and you will become the corporate members. So the step 1, as I just mentioned just now, the accredited engineer degrees. If this university is an accredited engineering degree, the graduate student must continue their studies in master. Otherwise, if they are unaccredited, the student might have to increase ataupun to add the other subject to become the accredited. So the next step is step 2. For the graduate engineer, you must apply or register to the BEM. And then step 3, you will need minimum 3 years of experience work in field engineer. There will become many more in field. You can pilih nak dalam kerja apa, asalkan dia dalam engineering field. There are more in our states. And then step 4, we will explain in details for the route A, route B, and route C. But I think I will fast forward, or I will details in route A and route B. But the route C is just like the route A. The difference is the route C, the examination from the IEEE, while for the route A from the BEM. So the assessment they call PAE. So for the professional assessment, for the route B, from the overseas, maybe chartered or integrated engineer. And then for the route C, just mentioned just now, the professional interview for the IEEE. So route A, if you pass, you will get the certificate of PAE. For the route B, you will get the professional award from the overseas university. And route C, you will become a corporate member. So Route B will continue for the exam of Code of Professional Conduct. So if you pass this step 4, you will go to the step 5. Step 5 for both for 3 of this route, you will apply for the professional engineer under the BEM, and then you will become the PE, professional engineer. So this is the requirement for the section 10 in bracket 1. Define the qualification for registration as a graduate engineer with BEM. A person who holds any qualification in engineering which is recognized by the Board of Nature shall be entitled on application to be registered as a graduate engineer, or you can say the GE. After you graduate, you must immediately register under the BEM to get your certificate as a graduate engineer. So the recognized academic qualification for the GE under the BEM include the engineering degree award by our country, Malaysia, engineer degree award by other countries overseas, and also graduate with engineering technology degree. These 3 is like the route A, B, C, which is Malaysia, in our country A, overseas B, and technology degree is C. So an engineering degree that has been recognized or accredited by engineering by the Engineering Accreditation Council, EAC. The latest list of the AEC is available in their website, while the recognition recognition of engineering degree from overseas will be based on the accreditation given by professional body. Is a signatory of Washington. So the next is graduate with degree in engineering technology is eligible to register as a engineering technologist. So this is the fee, processing fee, registration fee, and the renewal. I will go fast forward. So the third last of the column stated by the body corporate, partnership, and so this is mostly for the route C, which is under the IEEE. So this is for the route A. So after the application method, we go to supporting application. You will now register it online, so there is no offline anymore. So after you register in my BEM portal, you must fulfill the supporting document. Applicant must submit this following support document that must be certified by the professional engineer recognized by BEM. For the Malaysia, you must have the degree school and official Sanskrit or CCM or DCAM for the aircraft maintenance license. For the diploma scroll and official Sanskrit, and lastly, you must have the identification card. For the non-Malaysian, you might also have these 2 and also your identification card, but you must also include the permanent resident or your passport, and also you must do in the translation. So next, after you go to the supporting, you must pay for the RM50, I think, for the processing fee, and then board processing time within 4 months, and you must and then you get issuance of certificate. So next, the principal examiner. First, the appointment, second examiner, and then 2 candidate on the date, place and time of examiner. So after the principal examiner, you go to the professional assessment examination. So the first one is professional interview, followed by essay writer. Before that, exam principal examiner is about you telling by yourself about yourself and what you do about your experience of work. For example, what project that you have involved. And then for the essay divide to 2 parts, which is part A is about your experience in project. It can be what you do in your field or your career within the period time of 3 years. And then for part B is mostly by the question you can go about for in the website of BM by itself. They are all about the question about ethics, what you can do and what the right thing as a professional engineer must do. So when second, exam aspect on understanding of an application of engineer principle to the solution of problems and the ability to communicate. Next, essay. Principal examiner, the appointment, second examiner, second right to candidate on the date, place and time of examination. Next, you go to the professional assessment examination. First, professional interview, just explain or introduce yourself and what are your project management that you've done. And then second exam aspect on understanding on application of engineering principle of to the solution of problems and the ability to communicate. And next, go to the essay. Essay divide to the 2 parts, which is part A and part B. The part A go to the project that you have involved in work experience, and section B is about ethics. And then you must wait for the PAE result, professional assessment examination. So within 6 months you will get the result. And then if you fail the essay or the PAE, you will repeat them once. Let's say for the essay you just repeat the essay, for the PAE you just repeat the PAE. So there are, you must appeal the result without within 21 days or 3 weeks, and then you must pay about 150, and you must receive the examination within a year. If you late for the 1 year time, then you will get a repeat from the started. Then if you pass, you will get the you will get the as the PE. So this requirement is mandatory for the university graduate, and then graduate student is person registered under the Regulation of Engineers 1967 by the BM, and graduate entitled graduate engineering title will get after the graduate engineer registered immediately after their graduate. So this BEM provide pathway for unrecognized engineering degree. This include the university that from the overseas, they must continue their study in master. The master program must be also related to the engineering discipline. And then if you don't want to go to the master program, you must top up course subject, top up a few lag subject in the university. You can check, but otherwise you can top up or you just continue master. So this is the document required from BEM. You can check on the My BEM portal. You must have copy IC, scroll. This is the 3 routes that I have mentioned just now. For the route A, you sit for the PAE, and route B, you can choose either you want to continue to the master or you top up subject. And by the route C, it corporate members of IEM, then you will just like route A. So for the route for the engineers, there are some of the design experience, means the period in MEMA or training, and then there are site experience. So this is the engineering branch related to sub-branch. This is the engineering practical training. For the electrical engineering specifically, the design experience needs 12 months. For the site experience needs 6 months. The design experience not really big, just a minor that you are involved project, such as maybe a transformer or the smaller subject. After the applicant has completed the requirement, the candidate can sit for the PAE conducted by the BEM, and then training must be conducted, and then the certificate should state the period of practical training. PAE eligibility for the grad engineers with 3 years of practical experience, and then the supporting documents for the PAE, same as the practical experience 3 years. You must declare, and copy of your GE, copy of degree transcript, at least the practical experience is minimum 1 year, 1 year experience in Malaysia. And then we will need the reports with form PAE, the work experience report, project report, and the certificate of drawing or document for the PAE. And then we will proceed for the payment. In total RM16 ringgit, and then you will sit for the board appointment and principal examiner, and inform candidate who sit for the principal examiner within 3 months of the date receipt. and then the principal examiner will appoint second examiner, and then go to the PAE, professional interview, with followed by the essay writing, and then some aspect on the understanding of application of engineering, and then same as the before, essay section A and section B, and they will given about 3 hours for the 2 sessions, and within 6 months the date of declaration will get the PAE result. If the PAE result is failed, then they are going to pay 150 within 21 days, and must be received within 1 year, unless the examiner want to repeat for the whole cycle. And then you will get pass is the document that you will need drawing that related to the candidate's own drawings. The candidate must be submit additional, not necessary, prepared by him to illustrate his experience in engineering works. Second is the feasibility study. The feasibility study involve the functional and academic comparison of the preliminary design of an engineering system and or a comprehensive report of a major engineering project. And the above shall include at least one relevant drawing, and also the preliminary stress or system analysis, and next the quantity cost analysis. And for the third one, for the operation or maintenance, this include the how to include the project about the maintenance or how to operate the system. And lastly, for the research, development and training. For the candidate engaged in research training, the candidate engaged in training must have 2 copies of report, or not more than 4,000 words. In evidence of the research carried out by him should be submitted, and then report must be include a brief summary of the candidate's research work, starting subject matter and objective, and also thesis prepared for higher degree, and then evidence must be provided that candidate has been at least one year of industrial experience, that as detailed of an application form and training and experience report. I think this